See, in this question what they have said, there is a RC smoothing filters. If you remember, I told you that why we are using filters, because in after using the rectifier we'll get the output in this form like the ripples. Okay, but as we know that we don't want ripples, right? So to remove these ripples we are using different kinds of filter. So in this they said they are using RC filter. Okay, frequency they have given this, that is 50 hertz. Again they have said for the half wave rectifier, R1 they have given and C2 they have given. So let's draw the diagram based on the RC filter. Okay, as they said for the half wave rectifier, so I'm drawing for the half wave. If they said for the full wave, you have to draw the diagram for the full wave. Okay, in the half wave rectifier, remember we'll use only a single diode, right? So in this we are having, as they said, C2 means there must be two resistance, sorry, two capacitance. One is the C1 and the resistance R1, and the another capacitance would be C2. Then we are connected with the load resistance, right? This is the load resistance we can connect over here. Now see, they have given the value of R1. R1 is how much? 100 ohm. C2 is 1000 microfarad. If 1 volt of ripple appears at the input of the circuit, input of the circuit means at the input side they have given, like at this particular side V1 would be equal to 1 volt. Okay, determine the amount of ripple appearing at the output. Means basically what they are saying like suppose there is a ripple of how much? 1 volt. Okay, this is a ripple of 1 volt maximum. Now you use filter over here. Okay, now what you want, that the ripple should be completely removed. Maybe at the filter which you are using, that would not completely remove the ripple. Maybe it will remove up to 90%, maybe it will remove up to 80%. So maybe in the output we'll get the voltage like zero point 0.1 volt or maybe zero point 0.2 volt. Okay, understood the question? What they have given, they have basically given the ripple of 1 volt. Now they are asking, now after using filtering, how much ripple must be removed, reduced. Removed is we can't say, right? So for that we are having the formula that the voltage, ripple voltage is equal to the input voltage, or we can say ripple input voltage multiplied by the xc divided by root of r square plus xc whole square. Okay, so in this case, as you know, xc is not given, but we can calculate the xc. How can we get the xc? Remember the formula, xc is equal to how much? 1 by 2 pi. Yeah, so 1 is there, 2 is there, 3.14 frequency also they have mentioned, that is 50 hertz, and capacitance also they have mentioned, that is 1000 microfarad. So it would be 1000 into 10 raised to power minus 6. Okay, if we'll solve it further, then we'll get 3.18 ohm. Got it? Now we can put the values over here. Input voltage is 1 volt, xc is given 3.18 ohm divided by root of r is how much? 100 square plus 3.18 square. Okay, so if we'll use ripple voltage in this case, after calculating it we'll get around 32 millivolt. So you can see that how much voltage is reduced. You have like in the input side we are getting the voltage of 1 millivolt, but in after using filter we are getting how much? 32 millivolts, and 32 millivolts in 32 into 10 raised to power minus 3 means 0.032 volt. There is a much reduction of the ripples in this case, right?